Hello and welcome to the latest edition of Technology Update, where this time we're looking at things a little bit differently. We're just peering through the keyhole of everything there is to see around us when we use the human eye on its own. So this month we're looking at the technological advances that take us beyond nature's boundaries. We're taking a look at all that's new in the world of optical technology. From the furthest reaches of the universe to the world we see around us every day. And we begin this month at the Special Astrophysical Observatory in the Caucasus Mountains near Karachevo-Cherkessia, a place that is the pride of Russian astronomy and where the modern idea of space research was first mapped out. The place where Russian scientists first pioneered a new global approach for the study of far-off galaxies.
With such telescopes like our instrument and other large telescopes all over the world, we can observe, astronomers can study the structure and physical conditions in the universe as they were more than 10 billion years ago. So this is machine of time.
Since the beginning of time, man has been curious about outer space, and in the 1970s the Soviet Union had a dream to create the most powerful telescope on Earth, to see as never before galaxies on the boundaries of perception. The brains came from St. Petersburg at one of the world's finest optical technology centers, LOMO, where it was designed. Not just the internal mechanism, but the entire method of mounting and directing such a vast, expensive and heavy instrument to monitor specific points billions of miles from Earth. Well, so much for the head, but the heart came from just outside Moscow, where they made the most accurate mirror on Earth at the time, one that could reflect to them the edges of space and time. Litkarina was one of only a handful of places where such a piece of technology could be manufactured, a factory where they focused on creating industrial components of the highest quality. Mirrors here are first forged, then cut and ground to approximate accuracy, before being polished using ultra-fine micro-abrasive lubricants to give them an unparalleled accuracy. It's here that they were charged with creating the biggest and most precise telescope of its time, the mirror that would reflect the edges of outer space. Well, it does give a perfect reflection, but I won't be finding a place for this mirror in my home. It's 6 meters across in diameter and weighs a whopping 42 tons. It's the one that was at the heart of the world's most powerful telescope for more than 20 years. Now, though, it's come home to the factory it was originally fabricated in for a complete overhaul. The reason? Tiny imperfections, some no more than 1 micron in size, that are causing it to give faulty data, meaning it's got to come up here for a smooth up and a polish off before it's ready to go back to stargazing, something it won't be doing again until 2010. But maintenance and after-sales service is just a tiny part of the work here. They still produce some of the finest components of their type in the world and are in international demand to create new ultra-sensitive mirrors to explore the universe.
There are quite a few companies in the world working with small optics, but very few that work with larger sizes. We're one of those very few. Our competitor in materials is a German company called SCHOTT, and there's a French company called SAGEM, which finishes the polishing of astronomic mirrors. We're the only company in the world that does both. We melt the glass and create a unique glass ceramic material known as astrocetal. And that's used for about 95% of astronomic equipment. And we process this material as well.
But when you're making lenses this big, they have to be flawless to degrees that make a millimeter from perfect seem like a mile. Although the forging, cooling and polishing are the beginning of the process, it's also important for the experts to know whether they've hit the target, because technology is far more powerful than man's ability with the human eye to judge it. So when they think they have it just right, it goes for fine-tuning and calibrating in a very special chamber. Well, I am making slow and exhausting progress. If this was a tower block, I'd be on floor 17 with 2 more left to climb. But this isn't an apartment block. This is one of the world's most expensive vacuum cleaners. Well, slightly more complex than that. It's a testing device for those high-powered mirrors we were looking at before, able to tell exactly where the focus lies. It's one of only 3 of its kind in the world, 72 meters tall, and designed and built in the Russian city of Severodvinsk. But when the team here were asked to create mirrors for Vista, Europe's new super telescope, even using a vacuum to adjust the curvature wasn't precise enough. A new method of achieving absolute perfection was required. Experts used hologram and laser technology to bring a fresh edge to the scrutiny these surfaces are examined to.
Here's the imitator we used to control lens correctors during the Vista project. They didn't produce such mirrors in the earlier years because, first of all, the technology was older. It was impossible to polish these types of tough surfaces, and control methods also lagged behind. That's why the holographic methods, and the ones developed by the Novosibirsk scientists in particular, allow us to get more accurate micron measurements, or even a more accurate holographic structure, to get the spherical wavefront we need for such surfaces.
Shining a hologram onto the lens creates an exact and very precise test of accuracy. Any flaws show up in a blur or fracture in the reflection, even to the most microscopic degree. Lenses are tested across the full range of their parabola before being certified as ready for use. And here in Novosibirsk, they create the lenses that are used to make those very exacting holograms.
Our pride is a big binocular telescope which was checked with our optical instrument. It's a huge telescope comprising 2 8.4-meter mirrors. It's located on a high peak in Arizona. It's one of the largest telescopes in the world. It was certified and verified with the use of our holograms.
High-resolution telescopes built on the blueprint of the Special Astrophysical Observatory are still leading the field, but are more than 30 years old in terms of technological advancement. But they are still evolving. Because of their accuracy, the data they create has long outreached our ability to analyse it. And so, in a kind of astrological post-production, new tools are constantly being designed to divide it into bite-sized chunks, spectrometers to divide the light into composite fragments.
For a long time, this technology was considered to be a toy of research groups, not just in our country, but also abroad. But in recent years, they've understood the great scientific potential of such observation methods, and now every big telescope in the world, and by big, I mean with a mirror diameter of more than 5 to 6 meters, it's equipped in this way. I have to say that the multi-pupil spectrograph, which has this block as its main component, is in big demand, not only here but also abroad, and we spend half of our observation time on foreign orders from Italian, French and other astronomers.
The Special Astrophysical Observatory changed the way we're able to see space, an engineering triumph in every sense. A massive yet sensitive instrument, hydraulically controlled to incredible degrees of accuracy, pioneering the modern age of astronomy. And it was the brainchild of the Lomo production company in St. Petersburg, world champions at creating optical technology. The advancements made here in every aspect of design came from Lomo, but are now used in every other world-class telescope, a Russian gift to the international study of astronomy. The biggest single advancement in everything we've learned about the sky at night in the past 30 years. No longer the world's best, but the father of all those that have surpassed it.